Hello, welcome to the fourth live session of the NPTEL Points in Topology course. This is Shovik and working with Skaslingam at Madras. This is the fourth live session. Okay, so yeah, okay. Before going for studying further, so there is one student join Mr. Mustaq. Can you please confirm whether I'm audible and is the screen visible to you properly? Mustaq, can you please confirm whether I am audible and is the screen visible to you properly or not? Please let me know. Okay, thank you, Mustaq, for confirmation. Okay, thank you, Mustaq, for confirmation. Okay, so well, so not many students have joined. So okay, so let's wait for a couple of minutes. In the meantime, let me give you a problem to you, Mr. Mustaq. So so in the so in the meantime, you may try to solve it. Else, I will explain anyway. So the problem is follows. Show that if x show that if CD is a separation of y, and if x subset of y be connected, then show that either x subset of C or x subset of D. So this is a problem. So you please try this problem by yourself for a few moments. I shall get back to you. Let's wait for a few more minutes. So there's one more student join, Mr. Rahul. Rahul, we have a one problem. The problem is as follows. So C and D be a separation of y, and suppose X is connected subspace of y, then show that either X lies within C or X lies within D. Okay. So please try to do it by yourself. Take your time. So the thing is that the definition of separation, all these things we have discussed in the last class, right? So I hope you can remember the definition, or you may also open the last class notes. Anyway, please try to solve this problem. Rahul, are you trying? If yes, please let me know.
Yes, sir.
Okay, please try. If you have any doubt in understanding the problem of this question, please let me know also. Are you able to figure out the argument, Mr. Rahul?
Sir, I have completed. I wrote S, C, and D.
Can you please be a bit louder? I'm unable to hear properly.
As C and D is separation of Y, so C intersection D equals to phi and C union D equals to Y. As X subset of Y, so X belongs to C or
One
X
minute,
belongs to
one
D.
minute, one minute, one minute. Hold on. Please repeat the argument one more time from starting onwards.
What, sir?
Please repeat the argument one more time from starting onwards.
As we are given C and D is a separation of Y, so we can write C intersection D equals to phi and C union D equals to Y.
Okay, correct.
As X subset of Y, so X belongs to C or X belongs to D. As we are here, we get C intersection D equal to phi. So either X is the subset of C or X is the subset of D.
Why? I mean, X subset of C or X subset of, I mean, one minute. So Y is equal to C union D. So some portion of X lies within C and some portion of X lies within D. Then from that, how you are concluding that the whole X will be inside C or whole X will be inside D?
As we get C intersection D equals to phi.
Huh, so what? I mean, the point is that suppose uh, this part is C and this part is D, and we may have X like that, isn't it? That is possible, right?
Yes, sir.
So, from how you're directly concluding that X subset of C or fully X subset of D? I mean, of course,
So
I hope you understand what I'm trying to say, right?
yes, sir. Yes, sir. Now I
Yes. So now please think one more time that what is the error. I mean, of course, you have to come up with some process to eliminate this problem, right? So please think, take your time. You have to use the fact that X is connected. I mean, of course, that's the extra condition you have to somehow use, right? So the extra condition which you have to use is that X is connected. Okay, please try to use. That means what? You have to use the method of contradiction. That means suppose we assume that some part of X lies within C and some part of X lies within D. Then from that you have to come up. We have to show that X is disconnected. So I mean, you have to use the contradictory process. Okay, so that is the thing. So please try to figure this out. Rahul, are you able to figure out?
Yes, sir.
Are you able to figure out?
Sir, in this case, we get two separation A and B of X, and as A is subset of C and B is subset of D. So we can't say like uh, complete X is either in C or in D.
No, no. Repeat your argument.
As you mentioned, this case,
Mm-hmm.
sum of X inside C and sum of X inside D.
Mm-hmm.
So there exists a separation
Mm-hmm.
A and B of X such that A is the subset of C and B is subset of D.
Okay, you say there exists some A, right? So what is that A? If you want to show separation, you have to come up with a specific A and B, right? Correct. So what is the specific A, and you also told B. So what is the specific B? I mean, the point is that this is whole of X, right?
Yes,
This
sir.
is whole of X, and this part is C, this part is D. So take this intersection portion. So take A to be C intersection X and B to be what? B to be D intersection X, right?
Yes, sir.
Then obviously X equal to A union B, and of course A intersection B empty, right? And so that means what? Then AB form, basically the AB forms a separation, correct?
Yes, sir.
Is it clear?
Sir, but here we can't say that the complete X is inside C or complete X inside D.
Yeah, but that is what the statement told you now, that X is connected, right? X is connected. But finally we come up with some separation A and B, which is separation, and of course A and B are non-empty. We have assumed already, right? Because because otherwise C intersection D. I mean, 1 minute. Here we have assumed that C intersection X non-empty and D intersection is non-empty. Otherwise, the intersection will not make sense, right? And this is the assumption. In that case, A union B equal to X and A intersection B equal to empty. So that is why A and B forms a separation. This is a contradiction to the given statement. Am I right? Is it? I mean, is it understandable to you, or is
So
it
we
need?
can't say that. So, sir, we have to show X is connected. So we have to show either X is completely inside C or completely inside D.
Yes.
But here we get a separation of X.
Correct. Correct.
So we can't say that X is connected.
Correct. 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 Absolutely correct. And this is the contradiction.
Okay, sir.
Understood properly?
Yes, sir.
Okay. Good. Okay. So next. So the next theorem which we are going to use, it is not a theorem, it's an exercise, but people say it's a theorem because it's a very useful result. So that's a theorem. But anyway, you please try to solve it first, then I will explain. Okay. X is connected if and only if any continuous function f from x to plus minus 1 is singleton. So the statement tells that f is connected if and only if its continuous image x to plus minus 1. Sorry, before that there is one theorem. Sorry. There is one, there is some I forgot. So there is a one theorem. Theorem is that let f x to y be continuous and x be connected. Then show that f of x is also connected. So I mean, so in compactness we have seen the same thing, right? So in this also we have to show this. So basically here you have to come up with some separation, and that means what? You need to assume that it's not connected. From that you have to show that x is not connected. Okay, So I mean, you have to use a method contradiction. That's the thing. Yeah. So please try to do it by yourself. Take your time. Are you able to figure out the argument, Rahul?
Sir, I am thinking that can we do like the mm, con- other side as we assume fx is disconnected and we figure out that x is disconnected like this.
So yes, so from if x is disconnected, you have to show that x is disconnected. How do you do that?
Mm, we take the separation of a and b of fx
Okay, so
and
if x equal to a union b, the separation, then
then we got as we have read in the set theory x equal to f inverse a union f inverse b.
if inverse a union if inverse b, correct? Then
So x equal to f inverse a union b. So if x equal to a union b, we get there.
no, no, I mean we have to show that x is disconnected, right? Again, why are you going back to f of x? We need to show what? We need to assume fx is disconnected. From that, we need to show the x is disconnected. Is it?
So
Is
here we get x f inverse A and f inverse B are two separation of x.
correct, correct, correct.
But I am thinking how can we show f inverse A intersection f inverse B equals to phi?
Because already a b separation of fx, their intersection is empty, right? This is clear,
Okay, so
right?
I will from the continuity infinity.
No, no, no. I mean, if it, then from f inverse a intersection b empty, and this f inverse of a intersection b, that is equal to a f inverse a intersection f inverse b. It is set theoretic thing. It has nothing to do with continuity.
Oh, okay, sir.
Is the argument clear to you?
Yes, sir.
Oh, okay. So the next question is that x continuous if and only if any continuous function f from x to plus minus 1 is constant. X is continuous if and only if any continuous function f from x to plus minus 1 is constant. Sorry, x is connected. It should be. I mistakenly wrote something. By the way, here plus minus 1 is mentioned. Instead of plus minus 1, it can be plus minus a also. So it has nothing to do with 1 itself. Okay. So yeah, please try. Of course, for this you have to use the previous fact that continuous image connected so disconnected. So please try to use that and figure this out the problem. Take your time. figure out how to approach this, or at least one direction at least.
One direction. I am figuring out the reverse direction.
Yeah, okay. So that means you have assumed that map is constant, and from that you show that x is connected. Is it clear? Is it true?
Yes.
Okay. Yeah, please continue. Tell me the argument. Tell me the argument. Yeah, please tell me the argument.
So first we have both the x is connected to then fx is constant.
No, no. Sorry, sir. Repeat again.
And first argument I have shown x is connected to
Hmm.
fx is constant.
Yeah, please show. Please tell the argument.
Mm, as x is connected and fx is continuous, so it sends connected set to connected set,
Hmm.
and we have a plus minus one is has a separation
Hmm.
1 and -1.
Hmm.
And so fx send the whole x at either at 1 or at -1. So fx is
Okay.
constant.
Hmm. Correct. What about converse?
And figuring it out.
So for converse, what you need to do for converse, you have to show that assume that f is constant, and from that you have to show that x is connected, right? Here
Yes,
also you have to use the method of contradiction. That means you have to assume that x is disconnected. From that you have to come up with some function from x to plus minus 1 which is not constant. Is the process clear? What is the process of doing that? You have to show that x is connected, so you are assuming that x is disconnected, and after assuming this you have to come up with some function f from x to plus minus 1 which is not constant. So it's a contradiction. Is the process clear?
yes, sir.
Yeah, please try to do it by yourself. Are you able to figure out?
No, sir.
Okay, so let me explain it. So okay, so before explaining, please let me know whether can you remember the pasting lemma. So there is something called pasting lemma. Pasting lemma, or sometimes it is known as gluing lemma. Do you know, um, or can you remember the statement of these things? Yes or no?
No, sir.
Okay, so let me tell you. So I am going to tell you the statement. I am not going to prove because it is given in a textbook for your convenience. I am just going to tell the statement of this lemma. So this lemma tells that
What, sir?
this this lemma I am going to state. I am not going to prove this lemma because the proof can be found in any textbook. Okay, for convenience, I am
Okay,
just
sir.
stating this lemma here. So the lemma
Okay, sir.
tells that suppose A and B be two closed subsets of X such that X union B, and let F A to Y, F1 F2 and F2 B to Y be continuous such that F1 and F2 agrees on A intersection. Then the function h from x to y defined by hx equal to if one of x belongs to A and if 2x belongs to B is also. So the statement tells that suppose if A and B are to closed subsets of X, and suppose X equal to A, and suppose f1 is equal to f1 f2 are mapped from A to Y, B to Y, which are continuous, and suppose the intersection, and suppose on the intersection f1 f2 agrees. Okay, so the in that case the function h defined from x to y, which is equal to f1 is equal to A, and on B it is f2 is also continuous. So this is the gluing lemma. Is this statement clear to you?
Yes, sir.
Okay. Okay. So now going back to the problem. So the reverse direction is what? The, re the reverse direction is basically to show that let f x2 plus minus 1 constant for any f. So assume x disconnected. So since disconnected, so let a comma b be its separation. So we can define f1 from a to plus minus 1 by sending everything to plus 1, and define f2 b2 plus minus 1 by sending everything to minus 1, and of course both are continuous. Then we can get f from a to plus minus 1 where x going to f1 of a x when x belongs to A, and going to f2 of x when x belongs to b, and this f is also continuous, and this is the contradiction. So are you following? I mean, is the argument understandable to you?
So here we are how we saying the continuity.
Okay, so this is what the content of the gluing lemma. In gluing lemma, what we have seen that uh, if f1, f2 are continuous function, they agrees on the intersection. The new function h, we are getting f1, f2 on a and b respectively, is also continuous. So this is the statement of the gluing lemma. Correct?
So here we get A intersection B equals to phi. So there is no F1 and F2 which is equal on any point.
That means what? That means f1 and I mean if the intersection is empty, so there is nothing to check. If the intersection is non-empty, in that case we have to check that whether f1 and f2 are equal or not. But since intersection is empty itself, so there is no harm. I mean, so we can say that f1 equal to f2 on a intersection b, because intersection is empty actually, right?
Yes, yes,
Understand?
yes,
Okay. So is the argument clear?
yes, sir.
Got it. Okay. So,
So sir, here we can write F is non-constant at the end.
sorry, repeat again.
In the proof of this, we have to wrote last line. We have proved F is not a constant.
So last slide we have proved that we can get a function f from x to plus minus 1 which is not constant, which is the contradiction to the hypothesis.
Yes,
Is it clear?
yes, sir.
Okay. So this particular result can be used for basically showing or for proving or disproving something is connected or not, right? Because it's an if and only statement. Correct?
Yes, sir.
Okay. So, 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 so let A subset of X and let A be connected. Show that A closure is connected. See, I mean, for this problem, you have to use that previous thing. That means you have to take an arbitrary control function f for plus minus one and show that it's a constant. Okay. So yeah, please try to do it by yourself. I mean, is it clear to you what is the process? What should be the process of approaching this problem?
No, sir.
See, we are going to use the previous criteria. That means, suppose f is a function from a closure to plus minus 1, then we have to show that f is constant. So, is it clear what we need to show?
Yes, sir.
Yeah, please try to do it by yourself. Take your time. Sorry for the inconvenience caused by me. So there is some technical issue. Wait, hold on, please. Okay, okay, Mr. Rahul. Can you please confirm whether I'm audible and the screen is visible to you properly? Anybody supposed?
Everything okay, sir.
Okay, thank you for confirmation. Okay, so what about this problem? Are you able to figure this out? This problem?
I thought if you could set x to 1 and x if x belongs to a and x to minus 1 if x is the limit point of a.
Just 1 minute. Can you please be a bit slower because I'm unable to hear you properly. Please be a bit slower. Please repeat again.
So we are taking the function x to 1 as x belongs to a and x to minus 1 if x is the limit point of a.
Uh, so, okay, so you are constructing a function here from a to plus minus 1 where a belongs to plus 1 if a belongs to a, and it goes to minus 1 if a belongs to limit point of a, is it?
Yes, sir.
But why it will be continuous in the first place?
What's sir?
Why it will be the continuous? Continuity is the thing, right? Because in the previous problem we have seen what? We have seen that where is the in the previous problem, we have seen that any continuous function, if is any continuous function, right, you have considered a function, that's okay, but why it will be continuous function? Is it clear what I'm trying to say?
Yes, sir.
Yeah, so yeah, please try to figure out why it will be a continuous function. Please take your time. What I will do, figure out what will be the possible argument.
No, sir.
Okay, so the argument will be as follows. Okay, so see, first of all, you have to show this thing. That means you have to show this fact that f is a continuous map from a closure to plus minus, so f is constant. It is any continuous map. Okay, it is not arbitrary continuous map we can choose. It is any continuous map to show. So f is some random continuous map x to plus minus 1. Okay, so this means what? A closure. Okay, now restrict f to a, and in that case it will be mapped from a to plus minus 1. Now a is given to be connected, so that implies what? F restricted to a, this particular map is constant. So let f of a is equal to 1 for all a. It is same as saying f of a is equal to singleton a. Now there is a theorem that f of a closure subset of f of k whole closures. Okay, and f of a closure is plus 1. Sorry, there is a mistake. I mean, it's a property continuity check f of a closure subset of f of a whole closure, and it is precisely plus 1. That means what? F of a closure is singleton set. Is the argument clear or not? Let me know. Is the argument clear or not? Let me know. Is the argument clear to you?
So f of a equals to singleton, and so f of a closure is empty.
No, no. 1 minute, 1 minute. Repeat again. Repeat again.
Yes, f of a is singleton set. So okay, sir. Yes, sir. Yes, sir. Okay, sir.
Oh, so is the argument clear to you or not? Please let me know.
Yes, sir.
So it's all clear, right? Okay, so the next problem is that let A alpha be subset of A and alpha belongs to index set. Be all connected so as the intersection A alpha non-empty. Then show that union of A alpha is also connected. So A alpha subset of X and each A alpha and all connects as the intersection is non-empty. You need to show the union of A alpha is also connected. Okay. Is the question clear to you? Is the question clear
Yes.
to you? Okay, so please try to do it.
I am thinking to use the pasting lemma as you mentioned above.
Okay, so tell me your argument.
I am thinking about taking an arbitrary function fx which tends to a1, which tends to a for all a belongs to a1 and
No, no, 1 minute.
a
So, are you trying to use the method of contradiction, or is it like that? Or are you directly trying to prove it?
directly trying to prove using pasting lemma.
No, no, the point is that, okay, understand, but you seem for in order to prove it directly, you have to prove it for all function f. You can't choose any specific function. Is it clear?
We are taking an arbitrary function.
Okay, choose an arbitrary function f from union of a alpha 2 plus minus 1, which is continuous. Then
And we are taking the f as the f1, f2, f3, which tends to 1
okay, so then f1, f2, f3. Okay, from f1 is what?
f1 goes from a1 to plus minus 1 and f2 goes to a2 to plus minus 1.
Okay, so basically you are trying to show that for each alpha you're considering this f alphas, right? So this is what you are trying to figure out, is it?
Yes, sir.
Okay, then
Sir, at each intersection we have empty. So using the pasting lemma, if alpha is not equals for some alpha,
no, no, that's
if we
I
put
mean no, no.
a1
First,
intersection
first tell me what is this function f alpha? What is this f alpha?
f alpha tends to 1, if alpha tends to 1, all right.
What do you mean by tends to 1? Alpha is an arbitrary index set, right? Here no limit, it is an index set. So what do you mean by f alpha tends to 1? Or am I missing something? What do you mean by something tends to 1? Is my question clear to you?
Yes, sir.
Yeah, what do you mean by something tends to 1? Because it's a index set. I mean, there is no limit, notion of limit in topology, right? So, yeah, so you have to show that chosen f is constant, right? Correct?
Yes, sir.
Yes, how to do that? Instead of a alphas, you can take a1, a2 for your understanding, and then the argument which you are trying to figure out for a1 and 2, then try to figure out for a alphas. Okay, so please try one more time.
So on this side, we can't do like this.
Yeah, tell me. Yeah, please repeat again.
So I was thinking that was wrong. I am not able to figure it out the way I was thinking.
Mm. Okay, no problem. Hold on. Okay, so the trick is as follows. And there is no trick actually. It's just a matter of observation. Hmm. So, whatever. Hmm. So, so if alpha, choose f restricted to each a alpha. Okay, why is not synchronized? One this. Huh. So if alpha is equal to f restricted to a alpha. Okay, and each a alpha connected. So that means f alpha of a alpha is singleton for our alpha. Up to this much clear?
It's
Okay. Now also it is given that intersection a alpha non-empty. So let T belongs to intersection alpha A alpha. So this implies f of T belongs to intersection of f alpha of A alpha. Correct?
yes.
And also it is known that f alpha A alpha each singleton.
So why we put AF alpha on the right side? We have to take F directly.
Sorry, repeat again.
We took the function ft, which belongs to intersection f alpha a alpha. Why we took f alpha? We took directly f instead of f alpha.
I mean, we choose alpha to be, we set the function f alpha to be f restricted to a alpha. Correct? It is a function, f alpha is a function from a alpha to plus minus 1. The reason why we are doing is that we have to at some point use the fact that a alphas are continuous, right? So in order to use something, a alphas are connected. In order to use that fact, we have to come up with a function f alpha from a alpha to plus minus 1. That is why this function a alpha comes to the picture. Is it clear?
Mhm. So that was clear, but in the last second line,
uh, Last second line, do you mean this one?
yes, sir. Here we took the left side f, but on the right side we took f alpha. Why?
Okay, no problem, hold on 1 minute. Okay, so t belongs to a alpha, right? So that means t belongs to a alpha for all alpha, correct?
Yes, sir.
So that means what, f t alpha, and this f of t is equal to f t alpha. Is it clear?
Yes, sir.
This line clear, is it correct?
Yes, sir.
Yeah. So that means what? F of t belongs to intersection alpha, f alpha of a alpha. Now, is it clear?
Yes, sir.
Okay. Now, f alpha, a alpha are singleton, and assume f of t is equal to 1. So this implies what? Each alpha f of alpha a alpha, that is equal to plus 1. Correct?
Yes, sir.
So this implies what? F of union a alpha, that is only plus 1. Is it clear or not? Is it clear or not?
Yes, sir.
Okay, very good. So, okay, now the next problem. So, now the next question. Why does not? So let an in the script from n equal to 1 to infinity be connected subsets of x such that an intersection n plus 1 non-empty. Then show that union an is connected. So the question is that in this here we have a a1, a2, an dot infinity, the connected subs of x, such that the consecutive intersection is a non-empty. Then we have to show that the union of an that is connected. Is the question clear to you?
Yes, sir.
Okay, in that case, please try to solve it.
Yes.
So are you able to figure out the technique or how to approach this problem? I mean, this problem is almost same as the previous one. Of course, you have to use your own mind to figure this out. So Rahul, are you able to figure this for yourself or for at least partially? Please tell me.
What, sir?
Are you able to figure this out this problem or at least partially?
Sir, I thought we took the same as the each f of fn an is singleton and an intersection an plus 1 equals to 5. So there exists t belongs to an intersection an plus 1. So f of t belongs to
But
f of
but here it will not work, right? Because here we did not I mean here we are not given a intersection. Here we don't have this expression, right? Here we have only consecutive intersection is not empty.
yes sir,
Correct.
we are working on the consecutive.
Okay, then tell me.
Mm, Fn equals to f restricted to n, f restricted to n,
Okay,
and an is connected. So Fn an is singleton set.
correct.
As an intersection n plus 1 equals to 5, so there exists some t belongs to n intersection n plus 1.
Correct.
Taking function on both sides,
Then
which belongs to f intersection f an intersection an plus 1 an intersection.
okay, then
So we took f, let ft equals to 1, so 1 belongs to f of an and f of an plus 1.
so one belongs to f of a n section f of a n plus one. Then
And f of an is singleton set, so all f of an is equals to 1.
correct.
So union is singleton.
Correct. Very good. Got it. Very good. Okay. So the next problem is that uh, show that one. Okay, so show that let E and A alphas are connected subspaces of X such that A intersection A alpha known empty for alpha, then show that A union of union A alpha is also connected. Is the question clear to you?
Yes, sir.
Yep. So let's try this. So this problem is also similar to the previous one, but of course, let's try to solve it properly. Take your time. So we were able to figure out how to approach this problem. We were able to
That
figure out. Yeah.
has been the same as the last case.
Uh, Same as last that understand, but tell me the argument.
So we get to each if we get two function f a and f alpha
Hmm.
restriction function. F a restricted to a and f alpha restricted to a. All f a and f a alpha is singleton set
Both single done. Okay.
and a intersection a alpha not equals to phi. So their existence t belongs to a intersection a.
Hmm.
So if if t belongs to f a intersection f alpha a alpha.
Correct only. Got it. Got it. I understood the argument. So yeah, that is very good. Yeah, it's correct only, right? Okay. Now show that if x and y are connected, then the product x cross y is connected. Is the question clear? Product of connected set is connected. Yeah, please try to do this. I mean, you have to start with f from x cross y to plus minus 1 and to show that f is constant. Okay, so please try to do it. Are you able to figure out the argument?
No, sir.
Okay, how you are trying? How you are trying?
Sir, I am thinking to take a strip or a line from the both sides
Hmm.
and we think to connect like somehow.
So the technique is as follows. Hold on a moment. Hold on. Hmm. So thing is, so we have f from x cross y to plus minus 1. Okay, and we choose x and y. Fix a point x naught, y naught. Okay,
Yes, sir.
now choose this slice. This is what this will be. What will be singleton x naught cross y. So if restrict to singleton x naught cross y, call it f1, and choose another slice x cross singleton y naught. If restricted to x cross singleton y naught, call it f2. Okay,
Yes,
now x and y both are connected, so that is why this x naught cross y and x cross y naught both connected. Is it clear
yes, sir.
now? Okay, now since both are connected, that means what? F1, F2, both constant function. Okay,
Yes,
so that means what? That means f of x naught cross y const singleton and f of x cross y naught, this is also singleton, correct?
yes, sir.
Okay, very good. So call this, so let it be plus 1 and this will be plus 1. No, no, okay, we can simply assume anything. Okay, so both are singleton sets. As well as from the picture it is clear that this point x naught y naught lies both in f of x naught comma y and f of x comma y naught, correct?
Yes, sir.
Okay, so that means what? F of x cross y naught and f of x naught cross y both are singleton as well as both agrees, correct?
Yes, sir.
So let call this plus 1. So till now what we have proved is that we have proved the value of the function on this part and on this part are exactly equal to 1, correct?
Yes, sir.
Okay, now now basically we need to show what? We need to show that f of xy is equal to 1 for all xy, right? Correct?
Sir, yes,
I
yes,
mean,
sir.
is it clear to you why we need to show that?
That we show connectedness of complete X and Y. X cross Y.
Correct. Okay. So that means we need to show this. Okay. Now, hmm, now the point is, so x comma y is some arbitrary point. Okay. And choose this line and this line. Okay. Now observe that we have already proved the value of f on this line and on this line is same. We have proved this, correct?
Yes.
Now this strip is intersecting this line, correct?
Yes.
So and this strip is also connected, correct? Because y
Yes.
is connected. So value of f on this line is constant, correct?
Yes.
but but in this line also value of f is constant is plus 1. So in throughout this full line value of f will be plus 1, right?
Yes.
And in this full line value of f is also constant, so value of f at the point x comma y is also plus 1. Is the
Yes.
argument clear to you or not? Let
Yes.
me know, or you may take time to figure things.
Yes. Clear, sir. So, sir, we can say the um, all the lines which are uh, verticals, all verticals line are connected to the line of X, not cross Y. So, in that way, all verticals lines, the
No, no,
constant
make
vector will be.
yourself understand what as you understanding this properly. No need to tell me. You understand first by yourself that whether you understand a full argument properly or not. Okay, take your time, try to understand yourself whether is it clear to you properly, and then let me know. Okay, yeah.
Understood, sir.
Okay, you understood properly, right? So, is it clear to you, right?
Yes, sir.
Okay, 1 minute, just hold on. Okay, so there is another problem. You may think, or you may think later on also. The problem is as follows. Where is that? Why is not coming in the first place? Hold on. Just hold a moment, please. Are you able to see the screen?
No, sir.
Okay, 1 minute. Sorry, there is a problem with the system. Okay, now are you able to see it?
Yes, sir.
Okay, so there is one problem you try at home. Suppose x, y connected and let A be subset of x and y respectively. Show that x minus A, now show that x cross y minus A cross B also connected. So in that case, you have two connected set and show that they are what? They are x complement of A cross B is also connected. This is what you need to show. Okay. So you may think this problem in your leisure time. Is the question clear to you?
Sir, please repeat this.
Sorry, repeat again.
Explain the question again, sir.
So the question is that suppose x and y two connected spaces and A and B are two subspaces of x and y. They need to show that complement of A cross B in x cross y is also connected. That means x cross y minus A cross B is also connected. This is what you need to show. Okay. Is the question clear?
Yes, sir.
Okay. Okay. So you can think about this question result time. You may tell the answer in the next session. Okay. So for today,
Okay,
that's all. So we shall meet on the next Sunday. Okay, thanks. I'm leaving the session.
okay, sir. Bye, sir.